Hello everyone, this is the teaser for the new feature for the post-processing plugin. So this is the plugin that could help you to apply some additional FX on top of the rendered image of the viewport. And to make it, it's quite easy. You have to have the view from the camera. And also you have to add the special user object called post-processing that you can find in a set browser in the shading elements you have here post-processing. So once the post-processing is active, we could enable one of the built-in effects here, for example, displacement, and we have our image outputted from the scene to be distorted according to the effect. And that was all nice and good, except the fact that we have just a limited amount of effects here. And that was a little bit annoying, and having a possibility to customize and make own effect, I think it's quite valuable point. In any case, this plugin is open source, and you always can get access to this code, modify it, add new effects here. But this is a very long and hard way, I would say. And just feel free to join Discord or write me by mail if you have any questions, you really want to learn more and go this way and implement your own effect, like hard-coded way. But my idea was to make it possible to have in a more user-friendly way. And one additional criteria for this feature is that we should be able to make a new effect without need to recompile the plugin and build a plugin. So it's done based on a fragment shader, and I'm going to show how it works. So this is the teaser for that effect. So in a set browser, we have new objects, new assets. So one is the post effect. So this is our base point, we're implementing our own effect. And another one is the effect shader. It could be several shaders if we want to have this chain of computations. For example, we want to take the current image, blur it, then compose with maybe color corrected scene image, and then maybe use depth to calculate some ambient occlusion, and then use a mask texture to, I don't know, to calculate screen space reflections or whatever we want on this specific effect. Yeah, so this effect, if we select this effect object, go to properties, we see that it's based on the shader file, and shader file is the OpenGL GLSL GPU shader. It's a fragment shader. So that means in 2D image, let's say our viewport is the image size of 1000 by 400, and we call each point pixel in 2D image. In GPU shaders, we call each point processed point texel. So basically this is the shading code. Let me show the shading code. I should have it somewhere by hand. So this one is the shading code. We have this test GLSL F. So it's a fragment shader. And so this is the logic which is running per texel for every texel we see on the screen. And this logic modify and calculate the output color. In this particular case, what we have here, so we have like hard-coded header. This is what we need to include for sure. So we have some input, which is text coordinate. So this is the position of our texel in UV space. UV space is in range between 0 and 1. So if you want to calculate the texel position or absolute position in image space, then you need to multiply this text chord by the resolution of the image. And resolution of the image is the you can get it by the system uniform called I resolution or G resolution. And for more information, I already added a page on the docs OpenMoBu.org, and it's called, under post-processing, it's called custom effect. So there is the list of the system uniforms, that could be helpful to implement your shader. So here the logic of this shader is simple. We have two input images. One is hard-coded, and this is what we got from the chain. So once we get to run this effect, what is the current image in the viewport we have? This is what we're going to apply our effect starting from this image. And this is the color we extract from like our input color. And this is our output color that goes back to the chain. And that could be used for the next effect, or that could be directly, if it's the last effect in our chain, that will be outputted directly as the new viewport image, and we will see post-process image on the screen. And then another sampler, this one already a user sampler, and we extract also a color from this sampler using the same UV coords. So in kind of image space, right? And the logic here that we mix two images based on the value. Value is our slider. So this is the uniform, which reflected in the user object as the property of the float slider clamped between 0 and 100. So we take this value, we mix two colors based on our slider value, and then we add additional static color, implemented also as the UI element for RGB color picker. So this postfix slider and postfix color is actually a special hints for the system to choose a correct UI element. So if we go back to Motion Builder, we could see that once we load the shader, this property is automatically populated according to our shader based on uniforms. So we have the slider. You see, I'm mixing two images. One is the original image, one is the blurred image. And then we also have my sampler. Here we could assign 2D texture, or we could assign another shader. If we don't assign anything, by default, it will be our chain image. So default image we have in the computation chain. And then the static color, which is some color that we add on top as the additional to our output color. You see, I'm just having this additional on top. And in our shader, this color is clamped. So this is to avoid this kind of saturation or artifacts with the color, because the RGB, we're not outputting in the high dynamic range, and the color of RGB, every component should be in range between 0 and 1. And then we have this output. So this is quite simple shader we have here. Yeah, and the blue shader is the built-in. So we have already one built-in effect shader, so that we don't need to implement on our own. We can't change actually the shader file because it's already integrated into the current build of the system. So it's effect that by default it's using the scene image, but you can also add any texture here or another shader as the input. So for example, you want to blur some sketchy modified scene. So you can put this input here at another shader which calculate sketchy effect, and then this shader will do a blurring, and then the main shader will mix all together on a specific logic that you want. And then, like for example, if I output here the full effect of the blur image in the blue shader, we could control the scale of it. Another cool feature I've added is the resolution. So all the images are processed in the full viewport size. But for some effects like blurring, for example, we could really speed up the effect by calculation in the half resolution of the image, or even quarter resolution of the image. And sometimes also this lowering down the resolution, down sampling, it automatically helps to make the image even more blurry in a cheaper way. Because when we resize the image down, we're already kind of losing quality a little bit to have its more smoothly result, more blurry result as the output. Yeah, and probably in this video I also would like to show some other effects that I implemented. For example, God rays. So yeah, we have the position. If we look at the shader effect, there are some extracted parameters here, and we have even position of a light that in a relation constraint we could connect the real light position into this shader. Probably we could do it even here right now very quickly. So if we go to constraint and we add the relation constraint, so we could have this effect shader, make it animatable and animate it, drag and drop as the receiver, and light position in world space as the sender, and connect them. So now you see when I move the light, it's automatically apply how effect is reacting, so how the volumetric lighting is calculated. This postfix WS to SS means that on our shader, the world space position have to be converted into the screen space position of the light in 2D space. So basically here we move it in world space, but when we get into the shader computation, we have this light as the X, Y in the screen space. But all this in documentation already reflected these details. Then we have number of samples, etc. And this algorithm, by the way, I took it from the shader toy, which is very great resource for many shaders, different ways of post-processing the image. And I also, in the documentation, I reflected what changes you need to do in order to adapt your shader toy shader into this fragment shader to be used here as the effect. So this is not really very something hard to do. It's quite easy steps. Then, for example, FXAA also adapted from the shader toy. So you see we have this progress bar. So on the left, it's showing the anti-alias smooth effect. On the right is the raw scene. So FXAA is based on the paper shared by NVIDIA, and it's a way how we can do some additional anti-aliasing smoothing in screen space. Then there is effect of sketchy. Also, I took it from the shader toy. So this is the effect of kind of sketch drawing in screen space. If we go to this effect, it has only one flag, Boolean flag, to turn different variations of this effect. So we could apply it like this or like this. All right, that's it for now, and looking forward to finish this update and share with all of you. Thank you for watching, and see you in next videos. Bye.